Welcome to this AQA GCSE Geography Revision Blast. This session is looking at tectonic hazards, which is part of Paper 1, the Challenge of Natural Hazards. So we're going to kick off the session with a game of altered vowels. Each of the key terms shown has the vowels changed to an alternative vowels. Obviously they are all to do with tectonics. Can you work out the key phrase? We'll pop each one of them on the screen for a few moments. At any point, if you need to pause to give yourself a little bit more time, please do. We will warn you when we're going to reveal. Our first one is on the screen now. Let's reveal. It is the focus. This is a point below the Earth's surface when the rocks give way in an earthquake. Number 2 is on the screen now. Okay, let's reveal. It is the epicenter, so this is the point directly above the focus where the earthquake hits worse. Number 3 is on our screen. Let's reveal. It is plate boundary, also known as plate margins. You possibly will see both of those terms in your exam paper, but we do tend to see plate margins more often now. This is a point where 2 or more plates meet, and therefore we would expect more tectonic activity. Okay, our fourth one is on the screen. Let's reveal. It's a Richter scale. This is a measure of magnitude of an earthquake. However, we don't tend to use the Richter scale anymore. It is seen as an outdated way of measuring earthquakes, although you will still see it in your textbooks. Finally, let's reveal. It is seismometer. So this is a machine that measures the vibrations from an earthquake. Well done if you got all 5 correct. If there's any of those that you're not sure about, go away and have a look at those definitions and try and remember those. It's really important to learn your key terms. Okay, moving on, we have a 60-second challenge. So on the left-hand side, you have 8 terms to do with tectonics, and on the right-hand side, you have got the definitions. You have got 1 minute to match them up. You might need a pen and paper at the ready here, so matching letters to numbers. Good luck. And again, feel free to pause the video if you need a bit more time. Okay, like we said during the music, if you need to pause to give yourself a bit more time, please do. We are about to reveal the answers though. Okay, so let's have a quick look. So we've got tectonic plate, giant sections of the Earth's surface, so lithosphere that's on the move. We've got convection current, heat from the core causes material in the mantle to flow. Subduction, where one plate is forced under the other, which takes place at destructive plate boundaries. Magma is a molten rock that flows underground, and when it's above ground we call it lava. Earthquake simply means the ground is shaking. We've mentioned the epicenter already, so it's a place on the surface where most of the damage is done. And then we've got the Richter scale, that old measure of the magnitude or the strength of an earthquake. Again, well done if you got all of those correct. Okay, we are going to do a quick give me 3. You've got until the time goes on the timer to give me 3 types of plate margin. Good luck. Okay, your time is up, so let's reveal the 3 different types of plate margin. So we have destructive, we have constructive, and we have conservative. Now, it's really important that you know what happens at each one of these. They're quite often the focus of 4-mark questions on that paper 1. So a destructive plate boundary, you've got 2 plates moving towards each other. So they can either be continental plates moving towards each other, and if that happens, then they when they meet, you tend to have fold mountains. More often, you have oceanic and continental plates moving together. Oceanic plates get forced below, that's called subduction. Okay, with a constructive plate margin, you have 2 plates moving away from each other, so you get giant rift valleys formed. And at conservative plate boundaries, you get 2 plates moving side to side, either in the same direction at different speeds or in the opposite direction. So what happens here is you can have huge builds up of pressure. They get caught on each other like a bit like a zipper, and over time that pressure builds and it can lead to hugely powerful earthquakes. So again, make sure you know your different types of plate boundary or plate margin. Okay, we're going to move on next to a bubble quiz. So with a bubble quiz, the number of answers that are correct can range from 0 to all 4. So you're going to have 5 questions. You've got to just work out how many of the answers that we're showing you are correct. Here's our first one. So a natural hazard is a natural event, threat to property, problem created by people, or a threat to people. How many of those do you think are correct? If you need a little bit more time at any point, please pause the video if you need to. Let's reveal the answer. It is A, B and D. So natural event, a threat to property and a threat to people. So it can't be classed as a natural hazard unless there is that threat to property and people. Which of the following are tectonic hazards? So hopefully this is a nice easy one. Tropical storms, volcanic eruptions, earthquakes or tsunamis. Let's reveal the answer. It is all of them apart from tropical storms, so B, C and D. Tropical storms are a weather hazard and we're going to cover those in a different revision blast. Where do earthquakes occur? So we've got plate margins, destructive margins, constructive margins and conservative margins. Okay, let's reveal the answer. It is at all 4 of them. Now in contrast, where do volcanic eruptions occur? We've got hotspots, destructive margins, conservative margins and constructive margins. What do we think? Again, pause if you need a little bit more time. We're about to reveal. It is all of them apart from conservative margins. So at conservative margins, there is no magma, which means that there is no volcanic activity. Hotspots are places like Hawaii, so not anywhere near a plate boundary, but the crust of the Earth is thin enough for the magma to break through. And finally, which areas have active volcanoes? We've got Hawaii, we've got the Pacific Ring of Fire, we've got the Mid-Atlantic Ridge, and we've got the San Andreas Fault. Okay, pause if you need a little bit more time. Let's reveal. Super. So Hawaii is part of a hotspot. You've got the Pacific Ring of Fire, which goes right around the Pacific Plate. You've got the Mid-Atlantic Ridge, where you've got lots of underwater volcanoes. And the San Andreas Fault has none because it is a conservative plate boundary, which goes down the side, goes along the edge of the USA, sort of through California, places like San Francisco and LA, for example. Right, we're moving on to a connection wall. So the connection wall has got 12 key terms. They can be grouped into 3 groups of 4. What we'd like you to do is to find the connection. So we'll leave it up for a moment on the screen as it is. If you need more time, you need to pause the video. Have a think about what they have in common. So these can be grouped into 3 key phrases. Though it does say 4 on the screen, we mean 3. That's a mistake. So each of the 3 groups has 4 phrases in. Again, you might want to get a pen and pencil or pen or pencil at the ready here to help you with this one. Pause the video if you need a little bit more time on this activity. Have you spotted the 3 groups yet? They are something that we have already referred to. Hopefully you have spotted that the 3 groups are the different plate boundaries or the different plate margins. So let's have a look at the answers and have a reveal. Again, if you're not quite ready, pause the video for a few moments. We're going to have a look at these groups. So firstly, we've got constructive plate margins. So constructive plate margins move apart. An example would be the Eurasian and the North American plates. The mid-Atlantic ridge has formed along a constructive plate margin, and you also get shield volcanoes at a constructive plate margin. We've then got destructive plate margins. So an example would be the Nazca and South American plates. They move together, subduction takes place, and we have composite volcanoes. So by process of elimination, we've got our conservative plate margins that move side by side. For example, the Pacific and North American plates. We've got the San Andreas fault that we've mentioned already, and they don't have any magma. That's why you don't have volcanoes along them. Okay, let's move on to a true or false activity. So hopefully, if you've been paying attention, these should be nice and easy. So firstly, tectonic plates move side by side at destructive margins. Is that true or false? We'll leave it on for a moment. Let's reveal the answer. It's false. That's what happens at a conservative plate margin. Right, tectonic plates move towards each other at a destructive plate margin. Is that true or false? Let's reveal the answer. It is, of course, true. Tectonic plates move away from each other at conservative plate margins. Now, if you were listening literally 20 seconds ago, you should know this answer. Let's reveal. No, it is false. Earthquakes are found at destructive plate margins. Is this true or false? Let's reveal the answer. It's true. Volcanoes are found at destructive plate margins. Is this true or false? Let's reveal. It is true. So at a destructive plate margin, when subduction takes place, you've got the oceanic plate being pushed into the crust, being pushed into the mantle, which then melts, causes that magma to occur. Right, let's move on to a game of red herring. So this time you're going to be shown 4 items and you need to say which is the odd one out and why. So let's do our first one. So which of the 4 items is the odd one out and why? We've got avalanche, we've got buildings collapse, we've got road surface rupture, and we've got people injured by falling masonry. So if you need a little bit more time, pause the video. So one of these is the odd one out. Let's reveal which one it is. It is an avalanche. The others are primary effects of earthquakes. Let's do the second one. Okay, this time we've got broken water pipes, we've got landslide, we've got tsunami, and we've got a food shortage. So which one is the odd one out and why? Let's reveal. It is broken water pipes. The others are secondary effects of earthquakes. Right, so number 3. Which is the odd one out in this one? So fertile soil for farming, job in the tourist industry, becoming a film star, geothermal energy. So pause if you need to. Let's reveal the answer. It is C. The others are reasons why people live near active volcanoes. Right, number 4. Which of the 4 items is the odd one out and why? We've got reading your horoscope, practicing school drills, training search and rescue dogs, and earthquake resistant building design. Which is the odd one out? Pause if you need to. Let's reveal. It is reading your horoscope, obviously. The other is strategies to reduce the risk created by earthquake. So practicing school drills in particular, a really good example of that is in Japan, where every September they have an earthquake drill day, a bit like we would have fire drills in the UK. Right, number 5. Which of the 4 items here is the odd one out and why? We've got measuring the temperatures of local rivers, monitoring earthquakes, keeping a lookout, and testing gases released nearby. Which of those 4 doesn't match the others? Let's reveal. It is keeping a lookout. So scientific methods used to predict volcanic eruptions are the other ones there. Okay, we now have 2 minutes to answer this 5, 4, 3, 2, 1 activity. So let's have a look at what you've got to note down in that time. So a lot to do in 2 minutes, so you might need to pause and give you a bit more time.
4, 3, 2, 1.
Okay, so this time we're actually looking at the Nepal earthquake, which lots of you do as a case study. If you've done a different one, you can obviously you can tailor your responses to that. So why was Nepal at risk of natural disaster in 2015? 5 reasons. 4 reasons why the 2015 Gorkha quake was so devastating. 3 primary effects, 2 secondary effects, and 1 sign that responses were inadequate. So 2 minutes, but again, if you need more time, you can pause once the music is over.
5, 4, 3, 2, 1.
Okay, how did you get on? If you need to pause the video, please do that now because we are about to reveal the answers. Okay, let's have a look at 5 reasons why Nepal was at risk of a natural disaster in 2015. Firstly, it's on a plate margin. There are many remote communities in rural areas, poorly constructed older buildings, steep mountain slopes, and it is in what is a low income country. So lots of factors there that would mean that it was less resilient to tectonic activity than other places. The 4 reasons why the Gorkha quake was so devastating. So it had a magnitude of 7.8, so anything over 6 is does generally result in loss of life, particularly if it's over 7, then it will be quite, that death toll will be high, which it was in this case. Shallow focus at a depth of 15 kilometres, so there's not much of that energy has been absorbed before it reaches the Earth's surface. The epicenter was 80 kilometres away from the capital city of Kathmandu. Again, not very far, so there's lots of damage done there. And it was climbing season in Mount Everest, which meant that there were more people in the area than usual. 3 primary impacts of the earthquake. So we had a death toll of 9,000 people. It's quite a large death toll for an earthquake. Lots of historic buildings were destroyed in the World Heritage Site in Kathmandu, and more than 1 million people were made homeless. 2 secondary impacts of the earthquake. The avalanches killed 19 climbers, and there was a loss of income from tourism. So Kathmandu took a really long time to get back on its feet after this. And 1 sign that the responses were inadequate, well, 1/3 of people affected were still in temporary housing in 2018, which is 3 years later. Right, we're going to move on to a connection spinner activity now. We're going to have a look at why people choose to live in areas at risk of tectonic activity. We have 6 factors on the board. So building design, poverty, water supply, infrequent events, ports and farming. So why do people live in areas at risk of tectonic activity? Let's have a look at where our spin is going to land. Okay, so we've got ports as our first one. So have a think for a moment about how ports has a link to why people would live in areas at risk of tectonic activity. I'm going to leave it on the screen for a moment before you reveal the answer. What do we think? How are ports relevant here? Right, let's reveal. So plate margins often occur on the coastline where settlements have been built up around trading links. So remember, if we think back to a few hundred years ago when people were exploring, particularly from Europe, they generally set up settlements in the first places that they got to. That's why you've got great big settlements along the coastline, particularly in places like South America. Right, where are we going to land this time? Okay, so we've landed on farming this time. So what is a link here? So why do people live in areas at risk of tectonic activity? What's the link to farming? Let's give you a moment. Okay, let's reveal the answer. So areas around volcanoes have really rich fertile soils, which is caused by the weathering of dried lava. So although it is very risky to live there, after a volcanic event, then you will have the benefit of those soils becoming richer and more fertile, so therefore more people can grow on them. However, there is also obviously a huge risk of a lava flow wiping out all the crops in the first place. Okay, let's spin again. Okay, this time we're on building design. So have a little think about this one. So how does building design factor in here? So pause if you need to. Let's reveal the answer. So building design means that buildings can withstand earthquakes. So again, if we think about Japan, so one of the world's richest countries, but also frequently suffers from earthquakes. So we've got things like cross bracing. So when you've got a big steel frame that goes right across the building that sort of holds it together. You've got rolling weights. Now rolling weights go with something else. So those great big skyscrapers that you see in Tokyo have huge big shock absorbers built in their foundations, which means when the earth starts to vibrate, when the earthquake is happening, then rather than just collapsing, those buildings will sway. However, the rolling weights on the roof of the building stops the swaying from getting out of control. You also tend to have things like automatic shutters on these buildings as well. So as soon as it detects a vibration, the shutters will come down on the inside and outside. So if any of the windows break during that shaking, then all of the glass is sort of safely trapped between those two shutters, meaning it isn't going to damage, it's not going to cause harm to people. Right, let's move on to the stepping stones activity. So a bit more of a challenge here. We're going to complete a chain of analysis to illustrate how we can mitigate risk of tectonic activities. So let's have a look at what we want you to do here. Right, on the screen you have 5 boxes. 2 of them have been covered for you, so there are a number of ways that we can mitigate the risk of tectonic hazards at the top. And then right at the bottom, we've got these will decrease the potential social and economic impacts of tectonic hazards, and they will keep the death toll low. So what we need is 3 boxes in between that act as stepping stones from the start of an answer to the end of an answer. So we might want to treat this a bit like perhaps a 4-mark question in the exam paper. And the exam paper could be explain how we can mitigate the risk of tectonic hazards. So it would be a good idea now to pause the video, what we need you to do is to note down what you possibly could write in those 4 boxes to construct a chain of reasoning that would get you from there are a number of ways that we can mitigate the risk of tectonic hazards. These will decrease the potential social and economic impacts of tectonic hazards, and they'll keep the death toll low. So while you're pausing the video, perhaps think about using some examples, think about the different ways that you can mitigate risk. Once you're ready, restart and we will reveal those answers. Right, let's have a look at how you got on. So if we reveal our second box, we can monitor areas at risk using equipment such as seismometers to detect movements underground to help predict an event. Let's look at our third box. In areas of risk, we can protect buildings by using shock absorbers to make the buildings sway rather than collapse, and add rolling weight so they don't sway too much. And then in our last box, we can also make plans such as practicing earthquake drills like they do in Japan and stocking up on supplies so we are fully prepared in an event. Now, if we have a look, we've got our introductory statement, we've got our little concluding statement right at the end, and our 3 boxes cover prediction, they cover protection in the middle, and then our 4th box down is planning. So the idea of that MP3, so monitoring, prediction, protection, and planning, all part of how we would mitigate the risk of tectonic activity. Right, I'm going to now move on to a 10-second blast off. So you're going to see some questions on the screen. You've got 10 seconds to answer them. Right, now, the magnitude of earthquakes can be measured by the Richter scale, which is a logarithmic scale. What does this mean? Now, I'm just going to add a little caveat here. We have generally stopped using the Richter scale. We still measure magnitude, but we don't generally refer to the Richter scale anymore. But it is something that is probably still in your textbooks. It is something that you will have heard of before. But it's a logarithmic scale. What does this mean?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Right, it means that it's a whole number jump on the scale indicates a 10-fold increase in power. So, for example, an earthquake with a magnitude of 7 is 10 times more powerful than one with a magnitude of 6, and therefore it is 100 times more powerful than a magnitude 5 earthquake. Second one, which is more so how much more powerful is an earthquake with a magnitude of 8 than an earthquake with a magnitude of 4? So a bit of maths going on here. Off we go.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Right, let's see if you've managed to work this one out. Is 10,000 times more powerful. So magnitude 4 earthquakes don't really cause much damage. They might knock the odd roof tile off, off a building. It feels a bit like a lorry rumbling past your house in terms of vibrations, whereas 8 is generally widespread devastation, huge death toll, pretty much the buildings raised to the ground, all sorts of things. What type of plate margin is not associated with volcanic eruptions?
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
Okay, so conservative, no magma. Right, that's the end of this revision blast for tectonic hazards. Hopefully that's given you a little bit more confidence with this unit. If you have a look at the playlist, we have got a revision blast for all topics. They might not be there at the moment, but over the next few weeks they will all be added to. So before your exams, please have a watch of all of them. And obviously, good luck.